What exactly is a magnetic field? You were probably taught in middle school that it's just an invisible force field, a magical aura created by special metals or running electricity. People say magnetism is one of the fundamental forces of nature. That isn't just a little wrong. It is fundamentally, entirely, reality-breakingly wrong. Here is a fact that should keep you awake at night. Magnetism, as a standalone force, does not actually exist. It is an illusion. It is literally just normal electricity moving so incredibly fast that the fabric of space and time starts to glitch out. You have felt this glitch yourself. Every time you snap two simple fridge magnets together, you are physically holding the bizarre consequences of Einstein's special relativity in the palm of your hands. Here's the part nobody tells you. The speed of light is literally crushing the space between those magnets. Today I'm going to show you how the universe takes simple, boring electric charges and bends space to create the invisible cosmic pulls that hold our galaxy together. Your reality is about to fracture. Let me show you. Close your eyes and imagine a lightning bolt. It splits the sky. Pure, raw electrical energy. Now imagine the Earth's massive magnetic field. Huge, silent, invisible. They look completely different. One is a violent spark, the other is a silent shield. But here is where your intuition fails. They are the exact same thing. If an electron were the size of a golf ball, the space around it wouldn't just sit there. It would stretch, it would warp. And when that golf ball starts rolling, the stretching turns into a twist. That twist is what we call a magnetic field. But wait. Why does moving change anything? How does motion create a completely new force? To answer that, we have to look closely at a piece of metal sitting on your kitchen fridge. Let's walk over to your kitchen. Grab a simple boring magnet off your fridge. Feel the cold, hard metal right there in your fingers. Now take a second magnet. Bring them close together. Snap. They pull together so fast it pinches your skin. You feel that invisible, violent tug. What is actually pulling them? People say, oh, it's just north and south poles attracting. Wrong. That is just a label. It explains absolutely nothing. Saying poles attract is like saying cars drive because they have a drivability. It is a lazy answer for smart people. Try this right now. Imagine chopping that fridge magnet perfectly in half. You might think you get a north piece and a south piece. Stop. That never happens. Instead, you instantly get two smaller magnets. Both magically have their own north and south. Chop it again and again. Keep chopping down to the bare atomic level. You never find an isolated pole. You never find a single magnetic charge. Now watch what this implies. If you can never actually isolate a magnetic pole, maybe magnetic poles don't exist at all. Exactly, they don't. So if there is no magical magnetic stuff inside that heavy piece of metal, what is doing the pulling? Look closer. Zoom in past the scratches on the metal, past the rigid crystal structure. Go all the way down to the individual atoms. What do you see? Nothing but normal electric charges, protons and electrons, just basic everyday electricity. But here is the trick. Inside a magnet, those tiny electrons aren't just sitting there. They are moving, they are orbiting, they are constantly spinning in perfect locked alignment. Billions and billions of tiny electric charges, all moving in the exact same direction together. That sounds impossible until you see the trick. It is the pure motion of those electric charges that creates the invisible snap you feel in your fingers. But how? How does simply moving an electron create an entirely new invisible pulling force out of thin air? To figure that out, we have to strip away the complex metal. We need to look at something simpler. We need to look at a simple copper wire. Let's strip away the cold metal of the fridge magnet. Let's look at something you see every single day, a plain, dead copper wire. Imagine holding it in your hands. Peel back the rubber casing. Look at the shiny, naked copper inside. Right now it's completely dead, electrically neutral, boring. Inside that copper, there are billions of stationary positive protons, and there are exactly as many negative electrons. They perfectly cancel each other out, a perfect, quiet balance. If you take a stray positive electric charge and set it perfectly still next to this dead wire, what happens? Nothing. No push, no pull. Total silence. Now hook that wire up to a massive battery. Flip the switch. Boom. A violent river of electrons starts flowing through the copper. This is an electric current. Just negative charges bumping and sliding down the line. But think about this. The wire is still electrically neutral overall, right? Exactly. Even though the electrons are flowing, there is still exactly one stationary proton for every moving electron. The math still balances perfectly. 0 net charge. But wait, it gets weirder. Take that loose positive charge from earlier. Now flick it. Toss it so it flies right alongside our live wire, moving parallel to the flow of electrons. Suddenly, snap! The flying charge violently swerves. It gets sucked straight into the wire. Wait, stop! Why did it get pulled? The wire is electrically neutral. A neutral object simply cannot pull a charged object. That breaks the fundamental laws of physics. People say the current created a magnetic field, and the magnetic field pulled the moving charge. Wrong. That is a label, not an answer. How does the neutral wire physically know the outside charge is moving? How does motion conjure a brand new pulling force out of absolutely nothing? If a wire were the size of a massive highway and the charges were bumper-to-bumper cars, half the cars are parked, red protons, half are driving, blue electrons. Perfectly neutral traffic. If you start running alongside the highway, does your physical running magically spawn a ghost force that drags you into the road? No, that sounds impossible until you see the trick. This one tiny detail changes everything. We are forgetting the most terrifying rule of the cosmos, a rule that doesn't care about wires or magnets or electricity at all. A rule discovered by a 26-year-old patent clerk named Albert Einstein. To see the invisible hands pulling that charge, we have to buy a ticket on Einstein's train. Let's travel back to 1905, Bern, Switzerland. Imagine standing on a dusty train platform. You hear the heavy rhythmic chug of a massive steam engine pulling into the station. Now, put a 26-year-old Albert Einstein on that train. He's staring out the window, watching the world blur past. He asks a simple, childlike question. What would happen if I chased a beam of light? Most people think light would just look like it's standing still. Wrong. People say speed is just distance over time, a simple, boring math problem. But Einstein realized something horrifying. The speed of light isn't just a speed limit for fast things. It is the absolute structural framework of reality itself. Let me say that again because it's massive. The speed of light is the maximum speed that physical causality can happen. Nothing can break it. Absolutely nothing. Now watch what this implies. Imagine you are on that speeding train, moving at 99% the speed of light. You hold a flashlight forward and flick the switch. To you, inside the train, the beam shoots away at the normal speed of light. But I am standing still on the dirt platform watching you zoom by. From my point of view, you are already moving at 99% light speed. Common sense says I should add your train speed to the flashlight speed. The beam should be going almost twice as fast, right? Wrong. Stop. I also see that exact same beam of light moving at exactly the normal speed of light, not a fraction faster. How is that practically possible? We both measure the exact same speed for that light, even though you are rushing and I am still. You're probably thinking, that makes no sense. Exactly. It breaks your brain. Because your brain thinks space and time are fixed, rigid things. They aren't. To make sure light always travels at the same speed, the universe cheats. Try this right now. Hold your hands exactly 1 foot apart in front of you. If you started moving at near light speed, that 1 foot distance literally changes. Time slows down for you, and the physical space, it literally squishes, it shrinks. The faster you move through space, the more the physical universe contracts to protect the speed of light. Keep that in the back of your mind. Because this isn't just a neat math trick, it is a physical, violent distortion of reality. But what does squishing space have to do with that dead copper wire? Everything. Let's unpack this squishing. It's called length contraction. Close your eyes and imagine a standard 12-inch wooden ruler sitting perfectly still on a desk. Solid, reliable, boring. Now imagine I pick up that ruler and hurl it past you at 86% the speed of light. What do you see as it whizzes by? Do you see a blurred 12-inch piece of wood? Wrong. You see a ruler that is physically, measurably shorter. It doesn't just look shorter, it is actively squished down to exactly 6 inches long. The wood hasn't changed, the atoms haven't broken, the actual, literal fabric of space that the ruler is occupying has been compressed. Here's the part nobody tells you. This isn't an optical illusion. This isn't a trick of the light. If you took a photograph as it flew past, the physical object is denser. The space between every single atom in that ruler has been squished together. But wait, it gets weirder. What if you were riding on that speeding ruler? To you, the ruler is perfectly normal, still 12 inches. But when you look back at me standing still, you see me and the desk flying backward at 86% the speed of light. So to you, my desk is squished. I am squished. This is the space-time glitch. Length and distance are not absolute facts. They change depending on how fast you are moving. You're probably thinking, that makes no sense. I never see things squish. Exactly, because in our slow, everyday world, the squish is incredibly tiny. It's like measuring a mountain with a microscope. You never notice it when you drive a car or throw a baseball. But what if you aren't a baseball? What if you are a tiny electric charge and you are surrounded by billions of other charges? If you cram billions of tiny things together, even a microscopic squish adds up to something massive. Let me say that again because it's massive. A tiny, unnoticeable squish multiplied by a billion creates a monster. This is where your intuition fails. You think the speed of light only matters for stars and rockets, but the universe is glitching out right in front of you every single time you flick a switch. Don't blink or you'll miss the actual magic. What happens when we apply Einstein's squishing ruler to the flowing electricity in our dead copper wire? We are about to unleash the invisible monster. Let's go back to the boring copper wire we hooked to the battery. Remember the violent river of electrons? They are zooming down the line. And our lone positive charge? We flicked it so it flies right alongside them. Snap! It gets sucked into the neutral wire. Let's look at this scene through Einstein's squishing eyes. This is where your intuition fails. First, let's stand on the floor and watch. From our point of view, the positive protons in the wire are perfectly still. The blue electrons are zooming down the line. Because the electrons are moving, Einstein says the space between them must squish, right? Wrong. Here's the part nobody tells you. The battery actually pumps them into the wire already moving. The space between them was defined when they entered the wire. To us standing still, the moving electrons and the stationary protons perfectly balance out. The wire is electrically neutral, zero charge. It cannot pull the flying charge. But wait, what if we don't watch from the floor? What if we ride along with that loose positive charge we flicked? Try this right now. Close your eyes and imagine sitting on top of that flying positive charge. You are flying perfectly parallel to the blue electron river. Now look at the wire beside you. What do you see? To you, the blue electrons are barely moving at all. You are flying right next to them. Relative to you, they are practically standing still. So they are not squished anymore. They spread out to their normal resting distance. But what about the red protons? To us on the floor, they were stationary. But to you, riding the flying charge, the protons are flying backward incredibly fast. And what happens to things moving incredibly fast? Exactly. They squish. Length contraction. The space between every single positive proton in that wire physically compresses. They pack together tighter and tighter and tighter. Now watch what this implies. In the exact same section of wire, you suddenly have fewer spread out electrons and way more densely packed protons. The balance is completely destroyed. To the flying charge, the wire is no longer neutral. It is glowing, screamingly positive. And what does a screamingly positive object do to a nearby positive charge? It repels it. It pushes it violently away. Wait, stop. Didn't we say it gets sucked in? If the flying charge is negative, the densely packed positive protons pull it violently inward. Snap! That sounds impossible, until you see the trick. The motion literally changed the density of electric charge in space. This one tiny detail changes everything. The wire isn't pulling with some magical invisible ghost force. It is pulling with raw, basic, overpowering electrostatics. It is simply pulling because relativity squished the protons into a denser cluster. The universe glitched and created an electric push out of nothing but motion. And what do we call this invisible push created by motion? We call it magnetism. Let me say that again because it's massive. That invisible pull we call magnetism is literally just basic electrostatics. It is entirely created by the relativistic squishing of space-time. When you see a magnetic field, you are not seeing a new fundamental force of nature, right? Wrong. You are seeing a massive illusion. You are watching plain old electricity distorted by the speed of light. People say, wait, electrons barely move in a wire. They drift slower than a snail. Exactly. They drift at fractions of a millimeter per second. You're probably thinking, that makes no sense. If they move so slow, how does relativity squish them enough to matter? Here is the part nobody tells you. The relativistic squish from a snail's pace is practically zero. It is microscopic. It is a tiny, insignificant fraction of an atom's width. But here is the trick. How many electrons are in a single inch of that copper wire? Billions? Trillions? Try 100,000 billion. If you take a completely insignificant microscopic squish and you multiply it by 100,000 billion, you get a massive, violent, undeniable shift in electric charge. That tiny glitch adds up into a monster force that can pick up cars in a junkyard. Now watch what this implies. If magnetism is just electricity seen from a moving point of view, then the magnetic field itself does not fundamentally exist. It is just a label we put on this specific space-time glitch. Think of someone you know who wears glasses. If they take off their glasses, the world goes blurry. Is the world actually blurry? No, it's a perspective trick. Magnetism is the blurry world. It is what happens when you look at electricity while moving. If you travel fast enough to catch up to the moving charges, the magnetic field vanishes. Poof! Gone. It completely disappears and turns back into a simple electric field. This is where your intuition fails. We spent centuries building compasses and motors based on a phantom force. We wrote textbooks about north and south poles, but they are just shadows on the wall, cast by moving electrons squished by Einstein's train. But wait, it gets weirder. If a simple battery and a wire can do this, what happens when the universe itself throws a punch? What happens when the speed of light doesn't just squish space, but actively carries the punch across the cosmos? Don't blink or you'll miss the actual magic. Let's zoom out to the stars. Let's zoom out from the dead copper wire on your floor. Look up at the night sky. Imagine the vast, empty darkness between stars. We know our simple battery pushes electrons to make a magnetic pole. But there are no batteries floating in the vacuum of space. There are no copper wires stretching between galaxies. Yet massive, swirling magnetic fields tear through the cosmos. They stretch for millions of light years. They shape galaxies. How does the universe create these monster pulls without wires? Here's the part nobody tells you. The universe doesn't need a wire. It just needs light. People say, light is just a color we see. It's just brightness. Wrong. This is where your intuition fails. Light is not just illumination. It is a physical, violent wave of pure electromagnetic energy. Let me say that again because it's massive. Every single beam of light, from a laser pointer to a distant star, is an electric field that is constantly, frantically changing. Try this right now. Hold your hand up to a bright light bulb. You feel the heat. That heat is invisible light smashing into your skin. But what is actually smashing? Imagine a single electric charge floating alone in space. Suddenly, you shake it. You jiggle it violently up and down. That violent jiggle sends a ripple out into the empty void, just like dropping a rock into a perfectly still pond. That ripple is a photon. It is a wave of light. But wait, it gets weirder. As that electric ripple flies through space at the speed of light, it is constantly changing its strength. And what did we learn about changing, moving electric fields? Exactly. The movement itself forces space and time to glitch. The changing electric field instantly spawns a changing magnetic field right next to it. They lock together. They dance. Now watch what this implies. The electric field creates the magnetic field, and the magnetic field creates the electric field. They push and pull each other perfectly forward through the absolute emptiness of space. That sounds impossible until you see the trick. This self-sustaining, leapfrogging glitch is what we call light. It is the universe's ultimate magic trick. Light itself is the physical manifestation of moving electricity squishing into magnetism. You're probably thinking, that makes no sense. Light is just a wave, right? Wrong. It is a space-time distortion, carrying the illusion of magnetism across billions of years. But how do we prove this invisible cosmic dance is real? We have to look at the tiniest, most boring object imaginable. Don't blink, or you'll miss the actual magic. Let's shrink back down to a piece of metal. Let's shrink back down from the swirling galaxies. Hold a simple, cheap plastic compass in your hand. Look at the tiny metal needle floating on its pin. Watch it jiggle. Watch it slowly, inevitably snap to point north. People say, the Earth is a giant magnet pulling the needle. Wrong. That sounds impossible until you see the trick. You are not watching two magical forces interact. You are holding a physical, tangible detector of space-time glitching. Here's the part nobody tells you. Deep inside the Earth, a massive ocean of liquid iron is spinning. That spinning iron is full of electrons, and those electrons are moving. And what happens when billions of electric charges move together? Exactly, they squish. The speed of light forces the space between them to contract. That massive planet-sized illusion of magnetism reaches up through the dirt. It reaches right into the palm of your hand. Now watch what this implies. Inside that tiny compass needle, there are also billions of spinning electrons. They are locked together in tiny atomic domains. When the massive squish from the Earth's core hits them, it physically shoves those domains until they align perfectly with the planet's glitch. Try this right now. Close your eyes and imagine the needle. It isn't being pulled by a ghost. It is being pushed by a phantom electric force born from pure motion. You are holding a device that proves the fabric of the universe bends. Let me say that again because it's massive. A $2 compass proves Albert Einstein was right. It proves that length and time are not fixed. It proves that moving electricity creates a monstrous invisible squeeze on reality. This is where your intuition fails. You thought it was just finding north, but you are watching the deep underlying rules of the cosmos play out in real time, right? Wrong. It isn't just rules. It is a violent, beautiful consequence of a universe built on speed limits. But wait, it gets weirder. If every magnet is an illusion, what does that mean for everything else we think we know? Don't blink, or you'll miss the actual magic. Because the rabbit hole goes infinitely deeper, and what it reveals about reality will permanently change how you see the world. So far, we've learned the biggest secret of physics. We've ripped away the cold metal of a fridge magnet. We've watched dead copper wire come alive with violently squished electric charges. We've seen that magnetism itself is just an illusion cast by Einstein's train ride. Now watch what this implies. Look around you right now. Look at the screen you're holding, the lights above you, the earth spinning beneath your feet. People say the universe is made of distinct, separate forces pulling strings. Wrong. That sounds impossible until you see the trick. The deep truth is far more beautiful. The universe is profoundly, intricately connected. It's not just a squished wire or a spinning piece of iron. It is the realization that reality itself is deeply fluid. Let me say that again because it's massive. What you see as a solid, undeniable force like magnetism is entirely dependent on how fast you are moving through the cosmos. This is where your intuition fails. We want the world to be simple. We want rigid rules and permanent labels. But the universe doesn't care about our labels. It operates on a terrifying, elegant geometry where space and time bend to protect a single speed limit. Here's the part nobody tells you. Every time you pick up a compass, you aren't just holding a tool. You are holding a physical manifestation of relativity. You are holding proof that the universe glitches, and that glitch creates the structure of our galaxy. It creates the light from the stars and the warmth of the sun. You're probably thinking, that is completely insane. Exactly. But it is the beautiful, undeniable truth of our reality. Don't blink, or you'll miss the actual magic. Try this right now. The next time you snap two magnets together, close your eyes and feel the violent pull. Don't just think of north and south. Think of the billions of electric charges racing inside them. Think of the speed of light crushing the space between your fingers. It's not just a magnet. It is the fundamental machinery of the universe, roaring to life in the palm of your hand. If you want to keep breaking reality and seeing the invisible gears of the cosmos, hit subscribe. Leave you something to imagine. What if the gravity holding you down right now is just another illusion of bent space? We'll talk about that next time.